Now that we've completed our gravity analysis and design in RISAFloor and our lateral analysis and design in RISA 3D, we can begin to use both programs to specify connections for design in RISAConnection. To begin, I'm going to go ahead to the connection rules spreadsheet here in RISAFloor. And to start, we can see that we have labels for each connection. So all the different, just basically the name of the connection. Then we have the connection type, a shear connection, a moment connection, brace, base plate, truss connection. And then within that kind of group, we have the specific type of connection that fits into that group. So in this case, a column beam, clip angle, shear connection. Now, each of those also have the ability to define the beam connection type, maybe bolted or welded, or the column girder connection type, bolted or welded. And some even have the option to set the eccentricity right here in the software. Now, if we wanted to, we could also add additional rows into this column. Say if we wanted a column beam clip angle connection, but we wanted the beam connection to be welded rather than bolted, or the column connection bolted rather than welded, we could set that differently so that those groups can be designed differently in RISAConnection. Now, once we close this out, we can begin to define connections on our model. So the easiest way to do this is to double click on a member and come into its properties here for connection. So we can define a girder beam to single angle connection on both ends of this particular member and click apply. We can go ahead and enable the visibility of these connection rules, and we can actually also see that each connection rule is assigned a color from the legend so that we can very easily pick out the connections we defined on the model. Now, obviously, this would be a very tedious task if we go ahead and double click on each and every member and go into the member properties to define the connection. So to do this more quickly, we can open up the graphical editing toolbar and select the beams and then select modify properties. And here I'm going to go ahead and enable that I want to use the start and the end nodes for the assigning of RISA connections. So again, I'm going to go ahead and choose girder to beam single angle connection. And I want to apply entries by clicking on beams individually. And I'm just going to go ahead and start to select those beams that are supported by girders in my model. And in this case, I'm just going to go ahead and do a few of them. These beams are between column lines 1 and 5. And so we can go ahead and assign those. Now I want to do the same thing with the beams that are supported by the columns. So I'm going to go ahead and recall the last dialog, and I'm going to switch this to a column beam single angle shear connection on both ends. And again, click apply and just start to apply to those beams found on those different column lines. And so we can just go ahead and apply these ones. Now, if we wanted to apply more, maybe this single selection of each connection type wouldn't be the best way to do it. We could actually use some of our selection tools to say, hey, I want to select all of my beams or all of my girders or all of my columns. And at one time, I want to apply this connection at both ends to all the selected members. That may be a more efficient way of doing things. Now, once we have our connections assigned, we can go ahead and choose to run our analysis. Now remember, we're only defining connections here for our gravity members. All of our lateral member design or design connections will be defined in RISA 3D. Analysis, in this case, will give us an enveloped moment or reaction at each end of a member. And that's important because that's exactly what we'll need to design different connections, shear or moment or brace connections in RISAConnection. Now, one thing that's important to remember is that RISAFloor is an optimization tool. So we never have defined, in this case, a specific shape to check. We're actually allowing the software to design and define the shape for us. And so in this case, if we make changes to the RISAFloor model that are going to update the beam size or the self-weight or add different loads or whatnot, obviously those changes are going to impact our connection design. And so we just need to be aware of that as we track changes and track the design downstream into RISAConnection. So now that we have the analysis complete, I'm going to go ahead into the director and choose RISA 3D. Now, obviously, we've defined our wind and our seismic loads in a previous session, and so we're not really going to worry about those in this case. All the loads are going to be written just like they were before, and we're going to go ahead and open up into our RISA 3D model. And so once our RISA 3D model opens, we'll see just the lateral system as we have seen before, and we can go ahead and disable some of these nodes in this case. And we can go ahead and disable the visibility of our nodes. And we can go ahead and disable the visibility of our node labels just to clean it up a little bit. So now that I have this, I'm going to go ahead and define our brace connections. So I can go ahead and do this in the same way as we did in RISAFloor. So I can double click on a member And under my End Releases tab, I can choose the connection type that I want to assign. In this case, let's go ahead and choose a diagonal vertical brace connection to be assigned at both ends. So I'll click Apply. Now again, if I want to see that visually, I'll just select to show my connection rules. And we can see that we have our one defined. We also have our connection rules coming from RISAFloor. So obviously this is tracking from RISAFloor into 3D, and then ultimately we'll track this into RISAConnection. Now, just like in RISAFloor, double-clicking on every member and assigning the connection type in the member properties is obviously a very inefficient process. So we're going to go ahead and assign these in a bulk way. So I'm going to go ahead and deselect everything, and I'm going to go ahead and use my select based on criteria. And so in the Members tab, I want to select all of my vertical braces because that's what I want to apply first. I want to apply my vertical brace connections. But I also need to choose all of my beams as well. And this is because RISAConnection looks at the connection at a node as an assembly. So basically, in the design, we have not only our braces, but also our beam being designed. And so if we were to apply brace connections on the braces and then a different beam connection here, we would actually get an error saying that we have discontinuity in connection. Basically, we have a mismatch of connections at a given node, and a RISAConnection wouldn't know what to do with that. And because of that, we need to define both on the braces and on the beam our diagonal brace connections so that they can be designed together. So I'm going to go ahead and click OK, and then opening up our graphical editing toolbar, I'm going to go ahead and switch to Modify Properties for beams, and I go ahead and choose to use both connection ends, I and J, to define our diagonal vertical brace connections. And then I'm going to apply this to all selected members. Now, one of the things I want to do, just for the sake of reviewing the results, is I do want to change some of these diagonal vertical brace connections to seismically designed vertical brace connections. Now, we do have the ability to do the AISC 34110 checks. Those were, that's something that we did in our previous RISA 3D session. And so I'm going to go ahead and double click on this member and just change this top beam here to seismic diagonal brace. And then in turn also change the J end of both of these beams to be our seismic diagonal brace as well. And so this way we can look at the way that RISAConnection designs these seismically detailed members. Now the last thing I want to do is I do want to define some column base plates with vertical brace connections. So I'm going to go ahead again and deselect everything, get a side view of the model, and then choose to select only the elements basically in the bottom of the model. So basically the braces and the columns. And when I do that, I can go ahead and do the same thing and choose to assign our connections. Now, I don't want to assign any connection type at the J end, but I do want to use the I end of the member, the start of the member, to assign our base plate with vertical brace connections, and we're going to assign them to all the selected members in the model. So now we have our base plate with vertical brace connection both on the column and on the brace, so we've got that match that we need. We can go ahead and turn on the visibility of everything so we can see that everything's matching, and this color coding works very easily in doing this as well to see exactly which connections are applied where and if they're matching at a given joint. Now before we go ahead and transfer the model to RISAConnection, I'm going to open our load combination spreadsheet. Now we reviewed this a bit in RISA 3D, but we want to go ahead and look at the Design tab because this is where we can actually set load combinations specific for the design in RISAConnection. And so these load combinations can be different than the ones we've run for hot rolled steel, or we could have completely separate connections that, or excuse me, completely separate load combinations that we didn't define for whatever reason. But essentially selecting these combinations here in this column are the ones that are going to be used in conjunction with the ones that are used in RISAFloor to design the connections in RISAConnection. So now I'm going to go ahead and click to solve our batch and our envelope solution. Now, why is it important in this case to run a batch and envelope solution? So we need a solution that is representative of the worst case scenarios that we find in the model. So because RISAConnection will read all of the end reactions from RISA 3D as well as RISAFloor, we need to include both the batch and the envelope solutions because the worst case, maybe axial, or the worst case shear or moment won't also always occur in the same combination. So this allows RISAConnection to evaluate all the possible load combinations and maximum reactions in order to provide a design according to what load is controlling. So now that we've completed our design here in RISA 3D, I can go ahead back up to the director, just like we did before, and transfer to RISAConnection. So again, just like we did from RISAFloor to RISA 3D, RISAConnection will automatically open. And the first thing we'll see is the groups of connections we have here. So those are just based on the groups that we defined, or the connection types that we defined. So we've got our base plate connection, our column beam single angle, our column beam single angle weak axis connection. Then we've got our girder beam single angle shear connections, our seismically detailed diagonal brace connection, and then our diagonal brace connections. Before we go ahead and do anything with these, let's go ahead and look at our settings. So under solution, we can see the code that we're using. This code is automatically defined, or we define this code in RISA 3D. So that's tracking into RISAConnection. Again, showing this as a process that kind of works together. Next, we can go ahead and see some different design parameters that we may want to, or design checks that we may want to enable during our analysis of these connections. So if we want to consider bolt hole deformation or rotational ductility, or we want to include the checking of the base material of the weld, we can do all those things. We can also choose what we want and save that as the default. In this case, I'm just going to click OK. And the first thing I'm going to do is I'm just going to solve the entire project. Just run through with the default settings and just solve every connection to see kind of where we are from a pass-fail perspective. And so we can see here in the Project Explorer very quickly that we do have some passing members, we do have some failing members. So let's go ahead and start by looking at one of these base plate with vertical brace connections. So I'm going to go ahead and click on M93 here. And we can see here by clicking on that, we're presented with the visibility of this. So here's the 3D view. And this is really one of the greatest strengths of RISAConnection, is the way we can view both the model in 3D and in 2D views, and also the way that we can view all the controlling limit states in a report. And so in the 3D view here, we can kind of rotate or orbit around this entire view. We can look at and see different things. We can select different things. So if I select the HSS tube here, we can see that the brace select section is automatically selected in the properties. I really like the 2D views. So if I look at the 2D views here, we get a top view. Again, we can select anything, maybe select the anchor bolts or the plate itself. We can select any of the dimensions as well. So we can select the dimension for the base plate, which automatically selects that. So there's really no guesswork. We can find very quickly exactly the properties or the dimensions or the elements that we want to change. We can also go ahead and look at a front view or even a left side view here. In this left side view, we can see very plainly the Whitmore section. And this Whitmore section is actually shown in red right now because it falls outside of the area of the gusset plate. And we'll go ahead and modify that in just a minute. So let's now go to the reports here. And the reports will plainly tell us exactly what is failing in this particular connection. So we can see in the summary here, we have a column base plate connection of failure in our anchor bolt shear. And we also have some failure in the gusset plate compression with the Whitmore section. And so if I click on the tab for base plate and expand the anchor bolt shear and the anchor bolt bearing on the base plate, we can see very plainly, okay, we were 31% overstressed. We have available capacity of almost 60 kips, and we can see exactly how that's been calculated here. And we have a required capacity of 78 kips, and that's from the loads that we brought through from RISAFloor and from RISA 3D. Additionally, those loads we can see are calculated based on a specific controlling load combination. And so in this case, it's selected for us the controlling load combination to be combination 4 from RISA 3D, and it's IBC 16-13. Now we could go ahead and select different combination, but it wouldn't be the controlling one. And so in this case, looking at the anchor bolt shear and the anchor bolt bearing, we actually need to increase the size of our anchor bolts. So if I come into the properties here, I'm going to go ahead and expand our anchor bolt section, and let's just go ahead and make this from 1.5 inches in diameter to 1.75 inches. Now automatically we can go up and choose to rerun this connection to see how that change has impacted our design. So we can see that we now have a passing kind of grade on our anchor bolt shear. So that's good, but if we look back at our unity check, we are still failing, and with a unity check of 1.0. So I'm going to jump back into my summary and see that the issue here in this case is the Whitmore section. So I'll choose the gusset plate here and see that the Whitmore section passes through an unconnected part of the gusset plate edge. And so if I go to my 2D view, again, we can see this pretty plainly in that the Whitmore section is drawn outside the gusset here in the bottom. And so in this case, I'm going to go ahead and select this dimension for the brace work point distance, and I'm going to start to change the distance. So if I go to 15 inches, that doesn't seem like it's quite enough. We can go next to 16 inches. And now that gives us something where it turns the Whitmore section to green. And so now if I go ahead and run the connection here, we can see that we have a passing unity check now. So we've completed this design of this particular member. And now if this was a similar condition that we would have on most places of the model or various other locations of the model, we could actually go save this as a default. So this could be our starting location, so we wouldn't have to manipulate the work point location, or we wouldn't have to change the size of the anchor bolts going forward. That would be the default coming from RISA 3D the next time we did a project or the next time we ran through this particular design. Now, the next thing I want to do, I'm going to jump back into kind of our main view of all our different groups. And I'm not going to spend any time looking at the column to beam single angle shear connections, but let's go ahead and look at the girder to beam single angle shear connections. Now, when we open this group, I think from the picture, it's pretty plain to see that we are going to have an issue in the way the connection is built. And we can see this really pretty simply, in fact, that we have a controlling load combination in most cases to be, load combination 16, but we have a unity check that's under 1, so at a 0.2, and it's still failing. So this tells me right off the bat that the failure is not from a particular design limit state, but one of a geometry restriction. And so if we go ahead and select one of these, so I'm just going to select maybe the first one here, we can see pretty plainly in the 3D view, or even in the 2D view, that we have too many bolts. Basically, our bolted connection, and in addition to our angle, doesn't fit within the web of the members. And so in this case, we need to go ahead and reduce the number of bolts we have in order for this to fit geometrically. And we can see that in our report as well. We can see that the geometry restrictions say that we don't abide by the minimum edge distance required. So back in the 2D view, I'm going to go ahead and click on the beam bolts and really easily just change those from 4 bolts to 3 bolts. Now I need to do the same thing with the girder bolts. Change those from 4 bolts to 3 bolts as well. And we can rerun the connection. Now the unity check increased a bit, and that's obviously because we have a smaller number of bolts and therefore less capacity in this connection. So we don't want to do this for every single beam to girder connection at the same time. So I'm going to go back to the entire group. And because we're selected on the group, we can actually go ahead and change the beam and girder bolts right from this interface. And so instead of various, we make this 3 bolts for the girder bolts, and then we make this 3 bolts for the beam bolts as well. And so now that we've made that change, we can actually solve the entire group. Now we're going to get a passing condition in most cases. Now there might be some other conditions where we have a much, much smaller beam where 3 bolts isn't going to work, but this gives us a better starting point to move forward in the rest of our design. Now again, if I jump back into our main screen here, let's go ahead and look at our diagonal vertical brace connections. So we have a group of those diagonal vertical brace connections. Let's go ahead and find kind of the worst case failure in this case to see basically what we would need to do. So in this case, I'm going to go ahead and maybe look at this M74, the I end, and M73, the J end, which gives us a unity check of 4.4 in load combination 5. And so that load combination 5 is a combination coming directly from RISA 3D. Now we can see here under the loading that we've got a shear loading, we've got a column force, and then we've got some pretty significant axial loads in our top and bottom braces. And that's to be expected when we have maybe a seismic or a wind combination. Now, as you can see, these loads are actually grayed out, so we could change them if we wanted to. So we could change this custom setting to yes, and we can enter our own custom loads. But in this case, we want to track with what we've done in RISA 3D and RISAFloor. So we want to bring those loads consistently from those programs. We don't want to change anything in that case. But let's go ahead and look at our reports to see kind of what our controlling limit states are. So when we start right out, we can see that we've got some failure pretty much everywhere. So maximum failure, though, in this case is at the top gusset to brace connection. So let's go ahead and choose the top gusset to brace connection. And we can see that our issue to start is our gusset plate compression in the Whitmore section, and then our brace weld strength as well. So I'm going to go here on the tab and choose our top brace. And so the first thing that we notice about this is we don't have enough available capacity, nearly enough available capacity, and we need to change or increase the area of our plate. So I'm going to go ahead and do that. I'm going to choose to increase this pretty dramatically from 3/8 of an inch to 1 3/8 of an inch, and go ahead and rerun that connection. So now that we have a passing unity check, we just need to solve our brace weld strength issue. And so let's go ahead and choose our brace gusset weld strength. And so we're not going to change the strength, but we do want to change the size in this case. So let's try maybe 9/16. And again, I'll run the connection. And so again, we get a passing grade in this case. Now, just to match, I'm going to do the same thing on the bottom brace. Obviously, we don't want any confusion maybe with the gusset size when it's getting fabricated. And we also don't want any confusion maybe with the brace to gusset or the way that the weld is created or added. And so I'm going to just go ahead and keep the same weld size and brace size or plate size, even if we maybe don't really need it, because we can see that the limit state for the gusset plate and the brace weld strength at the bottom gusset to brace connection is quite a bit lower than that top. And that's because we have a smaller axial load in the bottom than we do in the top. Now, if we go back to the summary, we've solved our issue with our gusset plates, but we do have some geometric restrictions, and we'll go ahead and look at those in a minute. But first, let's go ahead and look at our beam to column connection. So if I look at our beam to column connection, we can see that we've got some edge distance failure and some other stuff. So maybe if we start to look at our 2D model here, we can kind of see what's going on. And again, we can kind of plainly see that we have a unity check that's under 1 at this point. And so that typically says to me that we've got a plate maybe that's too big for a flange connection or something else. So let's go ahead and look at the front view. In this case, obviously it's pretty plain to see. Now, one of the ways we can solve this is we can change the connection type or just reduce the size of the angle. In this case, I'm going to select this first connection, and I'm actually going to make this beam to column connection not be a double angle, but just be a shear tab. And so if we go back to our reports here, and we rerun this particular connection, now we've got some flexural yielding in the plate problems and some welding at the plate problems. So I'm going to go ahead and change this plate section. Let's make this, maybe see if a 1/2 inch will work. And so a 1/2 inch seems to work for our plate flexural yield, but we do need to increase the weld at our beam. So let's go ahead and change our beam weld to be not 4/16, but maybe 5/16. Okay, so we're now passing because of that. We're not failing because of that plate. Let's go back to our 2D view, and we need to decrease the size of these plates. So I'm going to go ahead and select the top plate here. We've got a 4x4 angle, and so let's go ahead and make that something quite a bit smaller. So maybe a 3x2.5 by 5 will work, and so that seems to fit on the flange. And then we can do the same thing by just selecting the angle coming down to the bottom and choosing again our 3x2.5 by 5. Now, one of the other things I want to do just for the edge distance, I'm going to go ahead and change this edge distance. I can go ahead and select those and say, let's make this 1 1/4, and let's make the edge distance for this bottom angle 1 1/4 as well. Just maybe fits a little bit better on our model. And again, I can run the connection and see now that I have a passing condition for this particular unity check. Now, if this was a problem, again, where we had these angles that were too big for maybe our small column, in this case, if we look at our general tab, we can see that our column is pretty small, a W8 by 28. We could go ahead and save this as our default setting, right? So that we didn't have this issue each and every time on each and every connection. Now, the last thing I want to go ahead and look at is let's go ahead and look at our seismic diagonal brace connection. So let's just go ahead and pick one of these here. And we don't have really any load in this. I'm not really surprised about that because this was just a seismic connection, and we don't have a lot of seismic load in this particular model. But let's go ahead and look at the report. And so for many cases, the controlling limit states are the same, the way that the plate shear yield is used or the beam shear rough shear. But we do have this seismic tab in this case. And so we can see when we expand this, we can see how the controlling load is calculated. So you can see all of these just different parameters. And again, right out of the code. So this is AISC 341 section F1.6a. So we can see where that's coming from. We can also see in our properties here that we're using the seismic system ordinary concentric brace frame. So we have that defined, and that was defined in RISA 3D. We set that in our RISA 3D session that we were going to use that type of brace frame. We can also go ahead and look at some other things. So maybe our seismic work point limitations or our weld limitations or even our yield stress limitations. Basically, just being able to expand all of these different things to see exactly what we want to see and to see how this seismic checks are going to be done here in RISAConnection. Now, if we go back to our kind of grouping of our connections, we've got some design, we've got others not designed, but at this point, we want to send information back to RISA 3D. Before we do that though, let's go ahead and look at creating a report here in RISAConnection. And so I'm going to go ahead and click the print report button, and our report printing interface is going to open up. And so here you can see kind of some of the basic setup options that are available. We can choose how or what views we want to include. So the 2D views, the 3D views. We can also choose if we want the full expanded view of the limit states. So basically every equation, all the information filled in. And that obviously that would give us a lot of different pages. So in this case, I'm going to choose just the fully collapsed view. We can also choose for any one of the connections we're adding if we want to use the governing load combination, or do we want to use a specific one? Again, that's up to us. In this case, I'm going to go ahead and just start to pick different members. So let's go ahead and add in, a base plate, and then I want to add in maybe column beam single angle shear, and then let's go ahead and add in one of our diagonal vertical braces. So let's maybe get to the one that we designed, click OK. And we could add additional information. So if we wanted to bring in additional PDF attachments, maybe we created a PDF of a detailed connection or something else that we designed outside of the software, we could bring that in and add that to the report as well. But in this case, I'm going to click Generate Report. I'm going to use Bluebeam, which is another Nemetschek product, and click OK. And then it's going to generate the report from us. And then we can go ahead and save the report after it's printed the entire report. So I'm going to go ahead and save this on my desktop. I'll just call this connection report, let's say -2, click save, and then it'll automatically launch this created report in the Bluebeam software. So with the report open, we can go ahead and just kind of scroll through the report, see the different views of the model. We can see the summary report and then the different limit states that are used. So this may give us enough information with the required and the available capacity, and then the unity check. And this will do this for all the different connections that we've included in this particular case. I'm going to go ahead and close out of our report here. And at this point, we want to take the information we've designed. I know we haven't designed all the connections, but we want to take the designed connections back into RISA 3D. So I'm going to use this export to RISA 3D. Before I do that, it is possible to detach the model. So basically, if we wanted to break the connection between RISA 3D and RISAConnection such that basically we didn't want to have the model or the information kind of integrated anymore, and we wanted to be able to change the beam size or the column size or the brace sizes that are defined in RISAConnect or RISA 3D or RISAFloor, we could use that detach. Now, when we do that, we will lose the loads. So basically the load combinations and all that will be gone, and we would just be inputting, basically using RISAConnection as if it was a standalone program. But that may be useful if you have maybe someone working on the superstructure model and then someone else working on the connection design. But in this case, I'm going to go ahead and choose to export to RISA 3D. And then RISA 3D will open up here, and we can see right off the bat on our connection design rule spreadsheet, the label, the member end that we're looking at, and the connection rule that's applicable. So in this case, for the most part, we're looking at our vertical diagonal braces, and then a pass-fail. And with a pass-fail, a max unity check if there is one that works, or if we have something like a geometric restriction, we're not going to get a max unity check. And so we can see this in a table, so we can include this in our output, or we can actually see this graphically in the model. Basically our passing and our failing members. So we can see this based on this connection legend that we have. Now, once this information is defined, again, we want to be able to include all of our reported information into one report. We can come back to print a report in RISA 3D, and we can add our connection design information. So if we scroll down here, we can choose our connection results to add those to this particular design report. We can also add a document here in this case, and I'm going to choose on my desktop, I wanted to add a PDF because that's what we created, and we can add that connection report. And then we can just add that report right into our output so that we can create this output that's exhaustive that includes not only the stuff from RISA 3D, but maybe also from RISAFloor or RISAConnection as well. Thank you for viewing this session of the RISA Steel Building Workshop focused on RISAConnection. When you're ready, please proceed to the next video, which focuses on RISA Foundation.